Good morning, children. Today, let us discuss about the metallic and non-metallic character across a period. Okay. First of all, just read that first line. Metals are donor of electron and hence forms positive ions. As you all know, metals are donor of electron. They always ready to give electrons. An example is written just below that statement. That is sodium minus electron. Minus means losing electron, and when an atom loses electron, it gains positive charge. That is why the right side it is Na plus. The same way, the next line, the nonmetals are called acceptor of electron. They gain electron and hence forms negatively charged ions. Example, chlorine plus electron, that means taking electron and becomes Cl minus. If an atom is receiving an electron, it becomes negatively charged. Okay, these are theory points and most of you already know the things, so I'm not spending much time there. Let me focus on the periodic property, that is in a period metallic character decreases and non-metallic character increases. Just to focus on this point, this is what we have to discuss in this chapter seriously. In a period, metallic character decreases and non-metallic character increases. We have to give explanation for that. And just bottom, just to focus my idea, one period, that is a third period is in front of you, starting with the sodium and ending with argon. Remember all the explanation which I am giving, this all the explanation is only up to the seventh group, that is up to chlorine. These explanations are not valid for noble gases, that is for argon it is not valid. It has got entirely different explanation. Okay, now the first thing, just see here, sodium has got a last cell contains 1 electron, magnesium with the red dots, you will find a 2 valence electron, 3 valence electron, here 4, 5, 6, 7, like that it increases. So metals are having 1, 2, 3 valence electron, and non-metals are having 4, 5, 6, 7 valence electron. So just see here, the first case sodium. Sodium need to donate 1 electron to become stable, whereas magnesium need to donate 2 electrons, whereas aluminium 3 electrons they need to donate. So if suppose somebody asks you which is more metallic and which is less metallic, the simple and the best answer is sodium is the most metallic element here, because it need to donate 1 electron. The atom which can readily immediately donate electron, that atom will considered as most metallic. So since sodium is having only 1 electron, it can easily donate electron and becomes stable. Magnesium need to donate 2 electrons, so that is much more difficult than sodium, whereas in case of aluminium it need to donate 3 electrons, so complication level increases. So sodium donate electron very easily, so sodium is considered as more metallic, and whereas aluminium is considered as least metallic in this case. That is why here written metallic character decreases. आगे जाने पे इलेक्ट्रॉन्स का नंबर बढ़ने से इलेक्ट्रॉन डोनेट करने में दिक्कत होता है, इसलिए मेटालिक कैरेक्टर आगे जाने पे डिक्रीज होता जाता है. Whereas in case of non-metals, silicon is having atomic number 14 with 4 valence electron. See, all the atoms try to become stable by gaining 8 electron in the last cell. This is the target of each and every element, to become stable by attaining 8 electron in the last cell. This structure is called octet structure, 8 electron in the last cell. Generally noble gas possess this structure. So here silicon need a electronic configuration is 2, 8, 4. It need another 4 more electrons to become stable, a tough job. Whereas in case of phosphorus, its electronic configuration is 2, 8, 5. It need 3 more electrons, so difficulty level decreased. Then in case of chlorine, if you see chlorine 2, 8, 7, it need only 1 more electron to become stable. That means this element chlorine will considered as the most non-metallic elements, because it need only 1 electron to become stable. So that is the most non-metallic element, whereas sulfur it need 2 electrons, compared to chlorine less non-metallic, and यहाँ पर 3 इलेक्ट्रॉन चाहिए. This is considered as again less metallic than chlorine and sulfur, and silicon it need 4 more electrons to become stable, and it's quite difficult job it is. So the most non-metallic element is chlorine, because it need only 1 electron to become stable. Suppose somebody ask you which is the most metallic and most non-metallic element. Very simple children, just remember this figure in your mind, a V, and आगे जाने पे this V metallic character decreases and non metallic character increases. मोस्ट metallic element आपको एक्सट्रीम लेफ्ट में मिलेगा, एंड मोस्ट नॉन metallic element आपको एकदम राइट साइड में मिलेगा. आई थिंक थिंग्स आर समवॉट आर क्लियर. And one explanation is I have written here, across a period number of electron increases, hence metallic character changes to non-metallic character. That is explanation. So read these points again and again, so that the things will be clear for you. Okay. Next, let me move on to the next definition called ionization potential. It's an entirely new topic given in class 10th syllabus, so you may not be knowing anything about this one. So first of all, we will by heart the definition of ionization potential. Just silently read that definition. The energy required to remove an electron from a neutral isolated atom and convert it into a positively charged ion is called ionization potential or ionization energy. Let me point out the main points. Ionization potential or ionization energy is the energy required. The energy required for what? To remove. What you are going to remove? An electron. From where? Entirely a neutral isolated atom. You are going to remove an electron from a neutral atom, not from a charged atom. And when you remove an electron from atom, you already know that atom turns into a positively charged ion. तो इन सिंपल लैंग्वेज, एक एटम में से एक इलेक्ट्रॉन निकालने के लिए जितना एनर्जी लगता है, एंड दैट एनर्जी वी कॉल इट एज आयोनाइजेशन पोटेंशियल और आयोनाइजेशन एनर्जी. Look at this example, sodium. Sodium is having 1 electron in the last cell, and by removing that 1 electron from here, it becomes Na plus. So once again, let me repeat the amount of energy required to remove an electron from an atom and converting into a positively charged ion is called ionization potential. Once again, let me repeat. एक एटम में से एक इलेक्ट्रॉन निकालने के लिए जितना एनर्जी लगता है उसको हम लोग आयोनाइजेशन पोटेंशियल कहते हैं, और एटम में से इलेक्ट्रॉन निकालने के बाद वो एटम पॉजिटिव चार्ज गेन कर लेता है. नाउ mainly as a 10th students, you have to see across a period what is happening to the ionization potential. Okay, just see the point here. It's very clearly written, in a period ionization potential gradually increases. When you move across a period, ionization potential gradually increases. Now we have to give explanation and we have to give reasons for that, and for that focus on this structure here. Okay, see again, sodium is having a 1 electron, last cell contains only 1 electron. Metal, sodium is ready to give electron, magnesium is also ready to give electron, but it has got 2 electrons. More energy is required, ज़्यादा electron निकालना है. Aluminum has got a 3 valence electron, last cell contains 3 electrons which are in red color. So when you move across a period, these first 3 cases, they are metals, they are donor of electron, they are ready to give electrons. फिर भी सोडियम के तुलना में aluminium find it more difficult to donate electron, because it need to donate 3 electrons. Donation means simply you cannot donate anybody. You need to find out an atom which is ready to take those 3 electrons. That's a tough job for aluminium. Whereas sodium, you will find so many non-metals from the 7th group, easily they take electron. Move to the right side. Here these are non-metals. Non-metal आप जानते हैं, they are not donor of electron. They are not at all donor of electron. They are not ready to lose electron. They are acceptor of electron. They are interested in taking electrons. So those who are not ready to lose electron, and from that atom, if you want to remove electron, you need to exert tremendous force there. For example, since in simple logic, my dears, at home also, if you are sitting with your brother and you are playing, and आपका भाई आपसे मोबाइल लेके भाग गया, इधर उधर जाने लगा या लेके गेम खेलने लगा, सो वो बिल्कुल आपको मोबाइल वापस करने के मूड में नहीं है, तो उनके हाथ में से मोबाइल लेने में आपको बहुत ज़्यादा जोर लगाना पड़ेगा. सो वो देने के लिए बिल्कुल रेडी नहीं है, तो जो देने के लिए तैयार नहीं है उनसे चीज़ लेने के लिए आपको बहुत ज़्यादा एनर्जी लगाना पड़ता है. सेम फंडा इज हियर ऑल्सो. एज यू मूव अक्रॉस ए पीरियड, these atoms are ready to lose electrons, so no problem, and they are not donor, they are acceptor of electrons. so आगे जाने पे इलेक्ट्रॉन निकालने में बहुत ज़्यादा एनर्जी लगेगा. सिंपल लैंग्वेज में आई कैन टेल यू इन अनदर वे, सोडियम के लास्ट में एक इलेक्ट्रॉन, 2-3 वैलेंस इलेक्ट्रॉन एक एक करके बढ़ रहा है. तो जितना ज़्यादा वैलेंस इलेक्ट्रॉन बढ़ेगा उतना ज़्यादा एनर्जी लगेगा इलेक्ट्रॉन निकालने के लिए. So across a period, for examination point of view, you have to see this one, ionization potential IP gradually increases. And in case if they ask you the explanation, simple, you can give any 2 points from this, maximum 2 points. Valence electron बढ़ जाता है. Valence electron means number of electron present in the last shell. और size decreases और न्यूक्लियर चार्ज इंक्रीजेस. साइज डिक्रीजेस में आगे जाने पे ऑलरेडी थियरी में मैंने बता चुका है, एक एटम इन ए पीरियड एटमिक साइज डिक्रीजेस, एटम का साइज डिक्रीज होगा, न्यूक्लियस के करीब रहेगा लास्ट शेल. सो न्यूक्लियस का पुल लास्ट शेल के ऊपर बहुत ज़्यादा रहेगा, तो जहाँ पर न्यूक्लियर अट्रैक्शन ज़्यादा रहता है वहाँ से इलेक्ट्रॉन निकालने में ज़्यादा एनर्जी लगेगा. ओके, सो हेंस मोर एनर्जी इज रिक्वायर्ड टू रिमूव इलेक्ट्रॉन फ्रॉम इट्स वैलेंस शेल. So in from this page, mainly 2-3 things you have to remember. At any cost you will by heart the definition, and then afterwards definition first, then across a period what happens, that point you will learn. Then third thing is out of these 3, at least 2 points you learn as a reason behind it. Okay, thank you children, that's all for today.